Hello, my name is Philip Walker. This is my capstone project for BDAN517, Western Kentucky University, for the business analytics portion of my degree. Super excited to bring these two data sets, R codes, to the video. So for my capstone project, I built and evaluated predictive modeling using two different data sets. My two different data sets were body fat or body measurements and loan results, loan data. The first data set is going to focus on predicting body fat percentage using body measurements. And the second data set focuses on predicting whether a bank would approve or deny a loan. So for both of these data sets, I followed the same overall process. Clean the data, split it into training and testing sets, built two different models, and really compared their performance on unseen test data. All right. So, without further ado, kick it right off with the first data set, which is my body measurement data set here. Looks like, all right, we'll go first with this one. So, as I said, first data set here, body measurement data set contains 252 observations, 15 variables. Some of these variables include such things as height, abdomen, weight, several other body measurements as well, as you see right here. All right. So first and foremost, started with loading my Excel file into the R. Then running my read Excel, my R part, which is going to help me build decision trees. Loaded up here, put that into my body data. Ran my NA emit, which is going to clean up any missing values. All right, next line. Set my seed at 1, 2, 3. Check my number of rows. Split the data set into training and testing data using that kind of 70-30 split. Making sure my split is reproducible. So every time I run the script, it's the same. All right, let's go down. All right, this is where we're going to get into training and testing my data. Hello, my name is Philip Walker. This is my capstone project for BDAN517, Western Kentucky University. Really appreciate you tuning in as this is the culmination of the end of my class here. Really excited to deliver this product to you. So without further ado, so this is my capstone. I had the opportunity to work with two different data sets here to show both prediction and classification. Really approached both of them kind of the same way. First, understanding the data, cleaning the data, making sure it's a good product, and then building and testing the models. All right, so we'll roll right into data set one, body fat off of the body measurement Excel file. So overall overview of this, 252 observations, 15 variables in this data set. This data set includes anything from age, weight, abdomen, circumference as far as variables, and this will help us as we ultimately go to try to predict body fat from these different folks within this data set. So main goal here was to keep the code simple and consistent as I continue to learn code, R code. So ultimately, starting out, just checking the structure of the data set, writing code to R code to remove any missing values here. That way we go into a clean train split. All right, so some of the models here, we used a multiple linear regression to predict body fat. I think overall the model performed well with low error and a strong test R squared, right? Which tells me the model explains a large portion of the variation, right? So ultimately, I feel like it did pretty well. All right, I'm going to move over to our loan application and go right into that one. So kind of same concept. So this data set included 272 observations and 15 variables, 12 variables. Let's take a look. All right, so kind of for how I approach this code for this one, follow the same exact kind of workflow, clean the data, split it, test it into two different models so I can compare results. Both built a logistic regression and decision tree here. Weirdly enough, both models ended up with the same accuracy, roughly around 78%. Let's see if I can pull it up here. Yeah, right here. Accuracy around 78%. Since they perform around the same, I would choose the logistic model. It's really easier to explain and interpret overall. In closing, this project challenged me, obviously, to kind of bring it all together, help me connect, how different models are used from a different model standpoint, depending on what you're trying to predict from a numeric or a categorical standpoint. Whether you're looking to make a yes or no decision, looking to predict a number. Ultimately, it was a nice culmination of the entirety of this